Hi everyone, welcome to our first video of the semester. Today we are going to be talking about solving a multi-step equation which is given in fractional form. Okay, so this is a type of equation that's going to require a few steps to solve, and where typically you have some kind of fraction in your equation. Okay, so let's say you are given something that looks like this. Let's say you're given -7 is equal to x plus 29 divided by -6. And we want to solve for x in this equation, okay? The very first thing we want to do in any equation, if we're trying to solve for some variable, is we want to try to isolate that variable on one side, and we want to get all constant terms on the other, okay? So let's go ahead and take a few steps to do that. The first thing we want to do is we want to see if we can clear this fraction. And to do that, we want to see if we can get rid of this -6, which is in the denominator. Now, when dealing with equations, one thing that you should know is that you can really do whatever you want to an equation as long as you do it to both sides of the equal sign, okay? I kind of like to look at the equal sign as like a scale. You can keep adding or subtracting weight from a scale as much as you want, and it will remain balanced as long as you are taking or adding weight in the same amount on each side, okay? So here, what we can do is in order to get rid of this -6, we can multiply the right-hand side by -6 in the numerator. And since we did it to the right side, we have to multiply the left-hand side as well by -6. So that'll keep the equation balanced. But since we multiplied the right-hand side by -6, these will cancel out. We'll have -6 divided by -6. That's equal to 1. So these can just disappear. And so now we are left with, we have -6 times -7. That's going to give us a positive 42. And that's going to be equal to x plus 29. Okay? So now what we're going to do is we're going to just subtract this 29 from both sides of the equation. Therefore, these will go away. And we'll have x is equal to 42 minus 29, and that's just going to be 13. Okay? Let's look at another example. Let's say you're given 5 is equal to x plus 28 divided by 5. Okay? Again, thinking of this like a scale, we have to do something to both sides of the equation if we're going to proceed. So let's go ahead and multiply the right-hand side by 5 with the goal of getting rid of this 5 in the denominator. And let's multiply the left-hand side by 5. Okay? These will each cancel. And now we're going to have x plus 28 is equal to 5 times 5, which is just 25. Now we can subtract 28 from both sides of the equation, and we're going to get that x is going to be equal to -3. Okay? And one thing that's always really pretty helpful in these situations, I should probably mention this, is what you can do if you want to make sure that you've done the arithmetic right, is you can take your you take your answer and you can plug it back in to the initial equation and see if it works. Okay, so here we have x equals -3, and we can just make sure that this makes sense. So let's take our initial equation, which is equal to 5 equals x plus 28 divided by 5. So let's see if that works. We have 5 is equal to -3 plus 28. And again, this is because we said x was equal to -3. So we'll have 5 is equal to -3 plus 28 divided by 5. And this is equal to 25 divided by 5, which that does work out to being 5. Okay, so we know that x equals -3 makes sense. So if you're ever on a test and you have a little bit of extra time, I would encourage you to check your work with this and make sure that your answers actually make sense. Okay, it's pretty simple in this situation, but later in the class there will be times where we will have different solutions to things, or things that appear to be solutions but don't end up making sense in the end, and you have to make sure that the end result actually makes sense. Okay, so let's go ahead and do one more example, and that'll be good for this video. Okay, maybe you'll get one that looks a little something like this. Let's say we have 3x minus 20 all over 4 is equal to negative 2. And you want to solve this for x. Now, this one looks a little bit more complicated, but the steps are actually still quite simple. We want to try and isolate this x all by itself. But first, let's isolate the 3x by itself. So to do that, let's multiply both sides of the equation by 4. And again, the goal here is we're trying to eliminate the 4 in the denominator on the left-hand side. Okay, so that will do that. 4 divided by 4 is 1. So these should cancel. And we're now left with 3x minus 20 is equal to negative 2 times 4, or just negative 8. Okay, now let's go ahead and add 20 to both sides of this equation. Okay, that'll take care of the negative 20 on the left-hand side. These will cancel. And we're left with 3x is equal to negative 8 plus 20. That is going to be equal to 12. Okay, so we're almost there. Now what we can do is we can divide both sides of this equation by 3. The goal here is to get rid of this 3 next to the x. So divide by 3, divide by 3. These will cancel. And we'll get that x is equal to 12 divided by 3. Or we know that is just equal to 4. Okay, and I'll skip it here, but if you want to check that this makes sense, plug a 4 back in into your initial equation, and you should find that if you plug that in, that will make the initial equation true.